Greetings and welcome to the instructional videos for the course. In particular, this is the first instructional video for Section 1.1 Linear Equations. So much of this section will be probably pretty familiar to you from your Algebra 1, Algebra 2 days. We'll just start with a little quick review of a few problems here. Remember, when you're solving a linear equation, which is of the form some multiple of x plus or minus constants, there's no exponent on the x like a squared or a cube, no x's in denominators, although sometimes they can turn linear. But our goal is to isolate the x, figure out what number would make it true. So in this first equation in the upper left, it says 4x equals 24, which means 4 times something is 24. Most of you intuitively know that would be 6. What we would do is we would do the opposite operation, which is divide by 4. That cancels the 4, we get x equals 6. Now, alternatively, and what actually works all the time when there's fractions is, instead of dividing, you can multiply by the reciprocal of the number attached to x. So that would be multiplying by a fourth, because a quarter times 4 is 1. And then over here, 24 times a fourth would be 24 over 4, which is, of course, 6. That's one of the first type of linear equations you've ever learned. Up in the upper right, that's a similar one. This is addition-subtraction. So if we have x minus 8 equals negative 11, we'll add 8 to both sides, and negative 11 plus 8 is negative 3. We can, of course, check our answer by plugging the x back in and seeing, is that true? X minus 8, negative 3 minus 8 is indeed, oops, missed the negative, negative 11, because negative 3 minus 8 is plus a negative. Now the bottom left, that's kind of your quintessential, like, two-step linear equation. That means you're going to do both those things. And what you do is you work your way backwards into the x. So we don't want to remove that 3 first. We want to get rid of the 4 by adding 4 to the other side. And we have 3x equals 17 plus 4 is 21. Now we can divide by 3, and we get x equals 7. Lower right, there we have some parentheses involved, so occasionally you have to distribute, and we have x's on both sides. So I'll distribute the 2. We have 2x minus 2 times 8 is 16. The right side is 2x plus 4. We'll subtract 2x from both sides because we want to get the x's together. So if we have x's on both sides of the equation, we want to sort of balance that equation by adding or subtracting those to the other side. But this one's kind of unique. We have a negative 16 on the left and a 4 on the right. It says negative 16 equals 4. That makes no sense at all. That's a false statement. So this is what we call an inconsistent equation, if it has no solution. So if we come up with a false statement like that, that would be an inconsistent equation. Now occasionally what you do is you might work down the equation, and instead of getting negative 16 equals 4, maybe you get something like 4 equals 4. Just a true statement that there's no x's left in it. That's known as an identity. That means any number solves it. Now, the other one, a conditional equation, that has a solution. That's another way of classifying an equation. So these other 3, they would all be known as conditional equations. Think of it meaning like they work under a certain condition. Like the first one works under the condition that x is 6 there. So a lot of those would be reviewed. Now if you get to the end of the section, it's a little bit more difficult. You might see problems like this one. Okay, so this is more your standard, really difficult linear equation with parentheses, but still all integers. And so here, there's kind of a set of steps you can really do to work forward. The first thing is always removing parentheses. So distributing is the first thing you want to do. Maybe 4x minus 32 minus 6 is equal to negative 2x minus 2, and then that plus 5. Now, before you start adding, subtracting numbers to opposite sides, you're going to want to combine. By combine, I mean something on the same side of the equation. So on the left, we have a negative 32 and a negative 6. Well, now to do negative 32 minus 6, and that's actually just negative 38. So we have 4x minus 38. Likewise, on the right side, negative 2 plus 5 is 3, so we have negative 2x plus 3. And from there, what we do is we want to isolate the x by getting all the x's on one side, all the constants on another side. So at that point, we're going to move. When I say move, I mean move across the equal sign one of the x's. And I always tell people move the smaller x. If you move the smaller x, you'll always end up with a positive x. So negative 2 is smaller than 4. I'll add the opposite of that, which is a positive 2. Then we get this. Now it looks like the problem in the lower left on the other slide. And so what we'll do next is move the constant. So when we move the constant, I mean add the number that's by itself, or I should say the opposite of the number by itself. So the negative 38, we add 38, and we have 6x equals 41. And then it's divide or multiply by the reciprocal. And at that point, you're going to have x by itself. So we divide by 6. X equals 41 over 6. I like that answer, an improper fraction. You are allowed to say that that's 6 and 5/6, or, well, if you like decimals, it's 6.83 with a 3 repeating, but that improper fraction looks nice too. So in this section, we look at linear equations, but we're going to look at a couple other ones. So in the next video, we'll look at how to deal with some fractions, and how later on to deal with absolute value.